I know piecewise functions can seem intimidating, but they are just multiple functions within a single function whose domains are represented by inequalities. A domain is the restriction replaced on the x values in a function. They can be seen visually by creating a table from the restrictions of the piecewise function you are given. The inequality symbols show that x cannot be more than 2 or less than 4 in this example. Therefore, the coordinates for this function are 2, 4, 3, 9, and 4, 16. Before graphing, note the inequality signs. Greater than or less than means that value is open and is represented on the graph by an open dot. It means the graph does not include that value specifically, but every value greater or lesser than it, depending. Greater than or equal to and less than or equal to signs mean that the value is closed and is represented by a filled-in dot on the graph. It means the value is included in the function's domain. In this graph, the 2 is open and the 4 is closed. Now let's graph it. Graph the points. Make an open dot for the point 2, 4 and a closed dot for the value 4, 16. Connect the points. Now, that wasn't really a piecewise function, it was only one piece of it. A piecewise function has multiple functions within it. So let's add one. The functions are arranged together with a bracket. Let's make a table for this equation. The only restriction x has for this function is it has to be more than 4, so the x values I use in my table are all greater than 4. The y value doesn't have to be exact when working with square roots. The dot also has to be open, because the first function's for value is a closed dot. The graph has no other restrictions, so it continues on forever in that direction, shown with an arrow. That's it, you're done. That's how to graph a piecewise function.
Let's start with something simple. Here's a graph with what would be a piecewise function. We will now figure out the written function algebraically. First, we will analyze a few coordinates from the grid. For the green segment, we have the coordinates 1, 1 and 2, 2. For the blue ray, we have the coordinates 4, negative 3 and 5, negative 5. And for the red ray, we have the coordinates 1, negative 1 and 0, negative 1. Then, as if finding a linear equation, find the slope of the coordinates, using the equation y sub 1 minus y sub 2 over x sub 1 minus x sub 2 equals m. Then find the y-intercept. Then put the slope and the y-intercept together to form an equation. For the green segment, this equation is x. This is only one equation for a piece of this function. Now, to finish this single piece, state the domain restrictions. For the domain restrictions, it is 1 is less than x, which is less than or equal to 4. Now it is your turn to find the equations for the blue ray and the red ray. Enjoy. This is the overall function for this graph. The blue ray and the red ray equations are stated here within the function.